found this large 360 aluminum extrusion in the scrap bin. It's perfect for the rat rig and it's free. I've made this simple plastic jig which will help me cut the extrusion. For the Y-axis I will need 30 cm in length. I will use the black permanent marker to mark the cutting lines for the extrusion. I've marked it all around, which will ensure that I've cut a perfect square. After removing the plastic jig, it's now ready to cut. I will be using my flex saw to cut the extrusion to proper length. It's definitely not perfect, but it will work. Next, I will make some screw threads with M8 tab. It took a lot of force for me, but I've managed to do the first hole. I've tapped the rest of the holes in the same way. I've printed my modified idler part using white PLA. I will upgrade it later with PETG, as this is the only test print this time. And now I simply push the extrusion inside the printed part. It was a bit tight, but I've managed to fit it inside. I will be using short M8 screws to mount the plastic onto the extrusion. With both screws installed, it's time to mount the side screws. For the side screws I will use those extrusion T-nuts which will hold everything together. T-nuts will automatically rotate when you tighten the screw. And after that it's pretty much done for now. I still need to install the belt idler, but I will do it later on. I've printed the motor holder for the other end of the extrusion. It's meant to work with NEMA 17. It attaches to the profile pretty much the same way as the idler piece. I'm using the exact same M8 screws as before. Screws are meant to hide inside the printed part. Don't use too long screws. For both sides I will use regular T-nuts with 4mm screw hole. I didn't tighten them yet, since it's best to align the print and profile horizontally on flat surface. After alignment, all of the screws should be tightened to prevent any loose movements. You should now be ready to install the stepper motor. I've grabbed this one from my stepper motor pile. I'm using my regular M3 screws to secure the motor in place. Motor connector should be facing bottom for easier wiring. As for the idler wheel, I'm using the GT2 6mm wheel with M3 hole. It rotates easily inside the printed part. There's also more space on the side if you want to use wider belt. I bought the Chinese Hewi knockoff linear rail. It's way cheaper than original Hewi rail, but it works really well. I've had some doubts at first, but I'm really impressed by quality. Carriage movement was a bit stiff at first, but it got better after sliding it for a bit. I've had to cut the rail by about 10mm since it was a bit too long. Idler part needs to be removed in order to install the rail onto the extrusion. I've prepared this simple 3D printed jig which will work as a means to secure the rail in place. I just couldn't find the 30-30 T-nuts with M3 screw hole. I've inserted the M3 nuts into the plastic and it's pretty much ready. I've put the jig inside the aluminium extrusion. It can be remixed to make it longer if there's a need for it. And now rail can be secured in place with M3 Torx screws. It holds the rail really well, but if you can, then buy M3 T-nuts. I've installed the idler part the same way as before. I can't get over how there is no loose movements at all. It's a huge improvement over bearings and wheels. I've printed the belt tensioning mechanism, which will also move the print bed on Y-axis. There should be enough space to put all the parts together, but not enough to let the belt slip out. There's a 5mm hole on the smaller part. This will make it possible to tension the belt later. I've printed the small cover as well, but it's not really required. This part will require 2 M5 nuts. I've put the 2 nuts on top side and secured them with 2 screws so they won't fall out. I will be using the reinforced GT2 belt for my printer. It's a bit more stiff than regular belt. I've put the one end into the printed part. It was a bit difficult since it's really tight. After that, I've put the smaller part into the bigger one. I've inserted the long M5 screw, which will be used as means to tighten the belt. After putting the belt onto the idler and belt wheel, it will be ready to install it onto the bed carriage. Second end of the belt have to be squeezed inside the round hole on the other side of the printed part. I've made the belt a bit loose so I can tighten it later on. It actually even works when it's loose like that. I've added the small zip tie where belt ends so it won't slip out in the future. It can now be safely tightened by screwing in the M5 screw. As you can see, the belt is now way tighter. This will make the bed move more precise. I've made this simple plastic plate to check if all of the holes are in correct spots. Everything seems to be in order. I've connected it to my Ender 3 for a quick test. It moves really smooth. I love how much better it is over the regular round rails. The Heatbed Gantry had to be split in 2 pieces. You could print it as one part, but you would need a pretty big printer for that. I will install the bed gantry in place of the test plate which I've installed previously. It's mounted well, but there is some flexing on the edges. I think if I add some more plastic to the design, then I could eliminate some of the flexing. The second part of the gantry is slightly bigger. This is because I've had to split in the middle of the carriage. With both pieces installed, it looks more and more like a proper printer. It still lacks a heatbed, which will make it look more professional. I've reprinted everything using the correct material and color. I think it looks way better now. I've also made a small bed carriage redesign. For the heatbed, I will use the 2 trees aluminium bed. Make sure that the wires are facing the motor. I will use 4 M3 screws to secure the bed on top of the carriage. Looks pretty well. Printed carriage has some issues with fitting, but nothing big. It's actually pretty sturdy thanks to the aluminium bed. For the heater, I will use the regular AC cable. It should be able to take a lot of current. There is some weird white stuff on it. I think it's glue. The power wire is supposed to come out of the same side as the thermistor wire. I've soldered the cable as 12-volt power input. I've had to change the routing a bit since the cable pushed onto the motor. Both cables now come out the side of the bed. I've also got these two small rubber feet which are meant for the 2020 extrusion, but those will work. Both pieces are meant to be secured with T-nut and M4 screw. Looks pretty good so far. Rubber will definitely make stuff more quiet. I'm going to wrap the cables with this ribbon-like wrap. I don't know what it's called. It might be a bit short, but it has to be tested yet. I'm left with this extrusion piece from cutting the Y-axis. This will be perfect for the Z-axis. This piece right here is meant to attach to the extrusion and combined with two rubber feet. The piece is meant to slide on the side of the extrusion. It matters on which one. You should attach it this way. I've used the M4 screws and T-nuts to secure it in place. It already works somewhat as a stand. This piece is used as a top cap. It makes the profile look better and also guides the lead screw. Mind the way in which you install the top cap, you have to retain the correct orientation. Top cap is being secured by the M4 screws and T-nuts as well. This time only one is required. Don't screw it too tight as it might separate the print layers and it will break. The biggest piece is for the motor. It's meant to attach directly onto the extrusion and hold the NEMA 17 motor in place. This one uses a lot of M4 screws and T-nuts. Once again, don't use too much force when tightening the screws. I'm using the motor found in my motor pile. I don't know the exact specifications. I've secured the motor with 4 Torx screws. It appears to be really stable. This time I've grabbed the 2020 V-slot extrusion. I will cut it into 40 cm piece. I've marked the cutting line to make sure that I get the length right. I will cut it using my circular saw. It's a bit rough on the cut edge, but it can be fixed with X-Acto knife. You can also use small Dremel tool to fix it. Edge is not perfectly flat, but it's okay since it will be covered by plastic end cap. End cap itself has been modified to use M3 screws. I'm using the same M3 screws as always. End cap holds onto the extrusion pretty well. There's also a second end cap for the other end of the extrusion. As before, I will use Torx screws with T-nuts. You can see here the correct orientation for both end caps. This is the piece which will hold the X-axis stepper motor. It's supposed to be mounted like this. As before, I will use the M3 screws with T-nuts. This time only 3 of them are necessary. I'm using flatter, lighter motor for this axis. Motor will be fixed using the M3 screws as well. Looks pretty good so far. This is the middle section extrusion. It's cut better than the other pieces. I've got it from my dad. It's meant to go more or less in the middle of the Y-axis. I will use this triangle plate to reinforce the connection and make sure that the frame is square. It holds both pieces well, but it's necessary to use 90-degree connectors as well. The other end is meant to connect like this, so there is some space for the rubber feet underneath it. For the Z-axis extrusion, I will use those big 90-degree connecting plates. Looks good so far, but it will need the 90 degrees connectors as well. It's starting to look like a proper printer. Here I've got the missing 90-degree connectors for the frame. I've also received pack of screws and T-nuts which will be required for the installation. I've removed one of the Z plates and loosened the other one so I can install the 90-degree connector. Connector makes sure that the profiles are squared. After that, I've installed back the plate and tightened everything. Now I have to install two connectors right here. Those will make sure that the Y-axis is squared as well. It looks way better now. It feels really sturdy. Rubber feet which I've bought seem too small, but those fit on the extrusion, so that's okay. Here is the slot for the rubber feet nut. Second one is hidden under the motor. I've removed the motor so I can install the second nut. I've pushed the screw all the way through the feet so it can be screwed into the frame. I've made sure that the screws are not too long. This could cause them to push against the motor. I've decided to remove the plastic wrap from my cables and replace it with shrink tube. I've chosen this blue one which will match the color scheme of the printer. I think it looks better now, but it needs some kind of holder near the bed. Now it's time to do some stuff with the X-axis. Linear rails finally arrived so I can install them. I will install the bigger carriage first. It's used to slide up and down the Z-axis. I've got the printed plate which will connect the carriage with the extrusion. It should be made of metal though. It will be attached with regular M3 short screws. You can see here the correct orientation for both pieces. I will use M4 screws to connect plate with the X-axis extrusion. It's not perfectly rigid, but I couldn't find the metal plate anywhere. The smaller rail is used for the X-axis. The Hotend assembly will be mounted on top of the carriage. I've cut the part of the rail as it was slightly too long. The rail is meant to be installed on the top of the extrusion like this. I will use M3 screws with T-nuts to secure it in place. I didn't populate all of the holes. It feels like that would be an overkill. I've secured it in place, making sure it's mounted in the middle of the extrusion. Now I can install the Hotend carriage. The bigger rail is used for the Z-axis. It's not required to cut it shorter. I've prepared a 3D printed nut holder which holds the rail on the top of the extrusion. I've inserted the M3 nuts inside the proper holes. I'll have to remove the top cap in order to insert the nut holder onto the extrusion. I've secured the rail onto the extrusion with nut holder inside. And now I can put the whole X-axis assembly on the Z-axis rail. I've put the top cap back and that's pretty much it for now. There are still some things to iron out, but it's definitely a start. Thanks for watching everyone, it was a really long video for me. I'm working on it every day, so there will be updates in the future.